In this video, I'm just going to show the intuitive idea of a limit. So here's a graph of a parabola, y equal x squared. And I'm going to do the limit as x approaches 2 of the function x squared, which is this parabola. So what is that? So the idea of a limit is, if you imagine getting on this function and you're sort of surfing on this function or skiing, and you're surfing coming from the left, so you get on the function on the left side of the point in question, and 2 goes here and goes here. So if I get on this function and I start moving from the left hand side towards 2, what y value am I approaching? Well, I'm approaching 4. Okay, and then you have to get on the function from the right side of 2, which would be up here, and surf towards that same spot. And what value am I approaching? I'm approaching 4 again. So this limit is 4, because that's the value I approach if I'm on it from the left. That's the value I approach if I'm on it from the right. So the value you approach from the left and the right have to be the same. So in other words, the left-handed limit has to be the same as the right-handed limit. And if it is, then the limit exists, and it's 4. All right, so here's the next example. So I modified this function a little bit, and now there's a hole there. So what is the limit as x approaches 2 of this function? I'll just call it f of x for now, because I modified it from x squared a little bit. So what happens? Well, if I get on this function from the left and I start surfing towards x equal 2, and I have to stay on the function, what y value am I approaching? Well, I'm still approaching 4. So now I get on the function from the right hand side of 2. So right hand side of 2 puts me up here. And then I'm approaching x equal 2 from the right side, and I'm still approaching 4. So this limit is still 4. Even though there's a hole there. So f of 2 doesn't exist, because it's missing. It's 1 point missing out of this. But the limit can still exist as I approach 2, as long as I approach from the left and approach from the right and get and am approaching the same value 4. So this limit exists. So let's look at the next modification of this same problem. All right, so let's say we got this. I'm going to call this one g of x now. I guess I got to call it g of x. This is different from my f of x in the previous example. Okay, so now I want to still do the same limit. Limit as x approaches 2. Now g of x. What does that equal? Well, do the same game. I get on, imagine I'm on the function from the left-hand side, and I'm surfing towards x equal 2, but I got to stay on the function, so I'm surfing towards it. What y value am I approaching? Well, I'm still approaching this y value of 4. So now if I get on the function from the right hand side of 2, which puts me up here, and I start surfing towards x equal 2, but I got to stay on the function, what y value am I approaching? Well, I'm still approaching 4, so this limit is still 4. Even though the value of the function g of 2 is not 4. G of 2 is down here, -2. So the limit as I approach from the left, the limit as I approach from the right are both the same. They're both 4, so the limit does exist and is 4, even though the value of the function at 2 is different. In this case is -2. So this is an example of where the limit is different from the value of the function at that point. And here is the next modification of this problem. I'm going to call this function h of x, just because it's different from the other examples. So the question again is, what is the limit as x approaches 2 of this function h of x? So what is this limit? Well, we do the same thing we did before. We have to get on the left-hand piece of this function. By the way, this is a piecewise function. This is the left-hand piece, and this is the right-hand piece. So we get on this function the left-hand side of 2, left-hand side of x equal 2. So we get on this function, this piece, and we surf towards x equal 2. And the question is, what y value are we approaching? We're approaching y equal 4. Okay? So then we have to get on the right-hand piece. So the right-hand side of 2, x equal 2, puts us on this piece. So we get on this, the right-hand piece of this function, and we're surfing towards x equal 2. And the question is, what y value are we approaching when we do that? And we're approaching y equal -2. So when we're on the left-hand side, we approach 4, and when we're on the right-hand side, we approach -2. Those values are different. So this limit does not exist, because the right-handed limit and the left-handed limit are different. So I can write down the right-handed limit. The limit as x approaches 2. I'm going to do the left-handed limit first. So this is the limit as x approaches 2 from the left. That's what this notation is, of h of x. So if I'm on the left-hand side, and I'm surfing towards x equal 2, I get 4. So the limit as x approaches 2 from the right of h of x. So if I get on the right-hand piece, surf towards x equal 2, what y value am I approaching? -2. So this right-handed limit is -2. So the limit as x approaches 2 from the left of h of x does not equal the limit as x approaches 2 from the right of h of x. So since these two limits are not the same, the limit in general does not exist. All right, so what is the value of the function at x equal 2? So h of 2, well, h of 2 is -2. So the value of the function exists. The right-handed limit exists. I'm sorry, the left-handed limit exists and is 4. The right-handed limit exists and is -2. But since the the left-handed limit and the right-handed limit are not the same. The limit in general does not exist. So hope that helps. Thanks.